Mine,
Ready to get started? Welcome. The Demo Ops meetup. I'm so glad you came here during Tech Week. A little sad that it is Tech Week because normally we're the only AI event in Utah, and this week every event's an AI event. So that's a sad day. I'm Mariah. I'm one of the co-organizers. We have Eric here. He's another one. He's in charge of all of our social media posts, which means he posts on LinkedIn and people show up.
That means that's all I do. So
I don't have to. This meetup is brought to you by Forge Utah. If you've never heard of Forge Utah, we're a local nonprofit. We put on tech events during more than just Tech Week, all year. All year we have tech events. We have a Slack group and a YouTube channel, and we hang out and nerd about stuff. We've been talking about DeepSeek recently because, it's everybody else's, right? If you'd like to join our Slack channel, just go to forgeutah.tech. That's our website. There's a button right on there that says join Slack. You click it. You find the machine learning channel and the data engineering channel and the random channel, and I think you're good. I think I've been distracted by the home lab channel recently because people are doing weird stuff with servers. But anyway, other announcements. Forge Utah is also putting on a hackathon, an AI hackathon this week. Starts Thursday night at 6 at ClearLink. Goes until Saturday. You have to turn in your project by Saturday, and then we're getting some cool prizes. I don't know. We're working on cloud credits. I don't know what else. Eric, what else? You're in charge. It's his hackathon.
I think there is money, and they're just trying to find out what to buy that's motivating, but also you could split with a group. So anyway, that's TBD. But there will be prizes. And there's gonna be food. Apparently 2 meals per day that we have full days, so that'll be cool. The prompt is going to be open-ended, so you can do whatever. There's a few different categories. So if yours is practical or if it's involved in AI or whatever, we'll vote at the end. And generally, I have 2 comments. So one, I think hackathons are generally the best way to make lasting relationships with people you don't work with, in your day-to-day. So if you're thinking about going to events in Utah Tech Week, I would prioritize the hackathon if you like that kind of thing. If you just want to do a project and meet some people or just mentor people. I mean, there'll be really good opportunities to do that. And then the other one is just going back to the Slack channel. Utah's got a couple communities, AI Utah's one. They have a Slack channel now, but it's significantly smaller. I actually think that Forge puts on 10 meetups. There's Golang, React, I think.
Yeah, so we have Go. We're affiliated with Utah JS has their own, but they double post Kubernetes. We have data engineering, and we have when we actually have a hack night where we get together bi-monthly and build stuff. So but everybody, we have also a channel where people just post all of the events in Utah. So the React meetup posts and the Flutter meetup posts and anyway, all of the meetups.
I guess my point there is I've noticed a lot of people come to meetups when they're looking for a job, which is great. I also think meetups are good. They're a good investment over the long term to make relationships. And so, but this channel is probably one of the bigger places you can go in Utah to actually meet people in Utah who don't show up here, maybe go to different meetups. So when you're looking for a job or looking for contacts or you're looking for prospective customers or something, this is probably one of the better channels you could be in, to get access to people. So anyway, that's it.
The Forge Slack does have a jobs board. It is the jobs channel. It's fabulous because the people that post there usually work for the company. So it's a referral. And then there's also jobs wanted where you can post your resumes and be like, hey, I'm looking for jobs and stuff like that. But yeah, we hope to see you at the hackathon. I'll be there. Eric will be there. My demo will be awesome if I get it done. So yeah. Cool. Just word of caution. This is a mic and that's a mic, and they're always hot, these squares. So they're great for asking questions, horrible for whispers. So just be aware. With that, I'm gonna turn the time over to Greg. Greg's got an awesome talk for us. We'll let him introduce himself, share his screen, and make sure you ask him all the questions because he's here as an expert. I'm never here as an expert, so. Turn over here.
Right. Your screen, your entire screen, focus mode in case any notifications pop up. Now we go.
That's great.
Cool. Okay. I don't know if I was doing the Slack thing wrong. I tried to join it, but this link doesn't actually do anything. It just takes you to
Which one? Oh, on Meetup?
this thing here.
Oh gosh, what did Clint? Oh, that's because that's the wrong URL. It should be forgeutah.tech, not the forge.tech.
So that doesn't work. I just thought I'd point that out.
Thank you. Well, I need to fix that. That's actually my problem.
Okay. Alrighty. I hate Canva. Okay. All right. I'm Greg Michelson. Happy to be here. Very glad to be talking to you about hopefully something that's pretty cool. Okay. Before we get started, just kind of to get the lay of the land, how many folks here work at a startup?
Ouch, that hurt.
Okay, so heavily about half at a startup. How many folks here are Python coders? So nearly everybody. R coders? No R coders. Not surprising. All are under the age of 50, so. How many of you have a title of data scientist? Some sort. Okay. What are the other titles? I'm surprised by. How many are like DevOps kind of people? Kind of.
MLOps, right?
MLOps, like,
Okay, yeah.
I do data engineering.
Data engineering. Okay. ML engineer. Okay.
AI engineer.
AI engineer. Okay, right on. Okay, these are all titles that are the same. Right, I got you. Data science, AI engineer. That works. All right. Let's see. By way of background, for me, let's see. So I have a PhD in applied statistics, but I started my career as a Baptist preacher. Hallelujah. Yeah, so kind of a winding career path. I started. I preached for probably 10 years, and realized that while that is an entertaining way to spend your time, it's mostly a PR gig. It's just trying to convince people to do stuff that they don't actually want to do. And while that's a good career, I thought to myself, you don't want to do this for the rest of your life. So I went back to school, went to the University of Alabama, studied applied statistics. I actually tried to get into their math program and become an actuary. That was the plan, the original plan. But the math program wouldn't admit me until I had a bachelor's in math. So they wanted me to go get a second bachelor's degree where I could enter the grad program or their math graduate program. But the business school was more than happy to let me in. And so I studied applied statistics at the College of Business. And that was probably the best, most luckiest thing that ever happened to me, because that was back before data science was data science. It was all statistics back then. And I started working in the financial sector. I worked at a Regions Bank. I don't think they have them up here. It's a Southeastern bank. And then the housing market collapsed. And I thought every day I'd be coming in to see the FDIC sitting at my desk. So I was like, I'm getting out of here. And so I moved to Connecticut and started working for an insurance company for Travelers Insurance. And there I met the guy who founded Data Robot. Who started Data Robot? You can make a movie out of that company. When I joined, there were probably 30 people there. We had no customers. Well, we had 3 customers that weren't actually paying us. They were like design partners to help us kind of build the product. Had about 30 people at the company. When I left, we had about 1,500 employees. Our valuation was somewhere around $8 billion. About 400 of them reported to me. I was the chief customer officer there. And we had about 150 million in revenue. So it was a wild ride to get there. And since I've left, probably the valuation is somewhere around $500 million. So the company's kind of imploded, primarily due to my leaving. Not true though. Kanza and I worked there together, and it was crazy. We went through 2 CEOs, like they fired the founders, like yeah, wild ride there. Learned a lot about the software business. I was started out as a sales engineer, so talking to customers, trying to figure out Well, I mean, the 2010s were like the year of the low code, no code, right? Where you're like mouse driven AI, anybody can be a data scientist, that whole thing. I think pretty well people have realized that the emperor's got no clothes on that one. That only the only people that are generating value with data science or with data are coders, are experts, people who actually know what they're doing. In fact, when I was a data robot, we spent all of our time. I had a team of 100 McKinsey management consultants, and all they did was go around from customer to customer trying to teach them why they needed machine learning in the first place. So it turns out it's real easy to sell AI software, but it's real hard to renew it. And that was probably the biggest problem we had at Data Robot, is people buying it and then never using it, and then going, why did we buy this again? And then canceling. So that was the biggest issue. So if you are at a startup and if you are in sales, keep that in mind. You really want to know who your target customer is. And sometimes not getting a deal is a much better thing than getting a deal and then not renewing it down the road. Because we did all kinds of crazy stuff. We did, these sales guys cooked up this plan to do 3-year committed ramp deals. So you give them a big discount in year 1, and then a smaller discount in year 2, and an even smaller discount in year 3, so that it would look like they were expanding over time. So you could artificially pump up your net retention to make it look like your business was growing. And then at the end of year 3, they wouldn't renew and everything would go to hell. So speaking of sales bros, you guys know, let's see, what is it? Sadness. Have you seen this? Sadness? Sales are dope. Never ever stop selling. So anyway, my last gig at Data Robot was working with the US government. When the pandemic broke out in 2020, it turned out that we looked at the CDC's forecasts for how the virus was spreading, and they sucked. They sucked really bad. And in fact, the CDC, about a year and a half later, stopped attempting to forecast. They just said, it's not possible, we can't do it. But of course, we had a CEO, our founder at the time, his name is Jeremy, was convinced that it was not only possible, but also really, really important that it get done, that we do the forecasting. And I'll explain why in a minute. And so he took about 100 engineers. Conso was one of them. I was another one. And we started trying to build a forecasting machine to forecast the spread of the virus at a county level on a daily basis. So we wanted to be able to forecast out 30 days on a daily basis for every county in the country. And so we ended up doing that with like some really complex kind of hybrid SEIR modeling and whatever the model was. It was a wild simulation that was primarily driven by like manual tuning. So it ended up being absurdly complicated. But the crazy thing about it was that we couldn't actually use Data Robot for any of it, our actual software for any of it. So we literally coded it from scratch. And that's, at the end of the day, the big problem with low code, no code solutions is that as soon as you sort of meander off the happy path, or there's something unusual about the particular problem you're trying to solve, well, suddenly the low code, no code stuff won't work. And you end up hitting the ejector seat and going and starting to write some real code. And that's certainly what we ended up doing. Now, the reason that we were building all this stuff in the first place is that we were trying to help the vaccine manufacturers make the vaccine trials happen faster. So this is a map off from the New York Times. We would look at this every day, and we would compare all of our forecasts with the county numbers to make sure we had this manual tuning process where we'd look at every county every day, and we would try and like tune the forecast to make them look sensible. And over time, they would get smarter and smarter, and that was that. But why would you want to do this? So it turns out that if you're, and remember, about 1,000 people a day were dying of COVID. And so there was a ton of urgency to like get the vaccine out there. Now, wherever you fall on the vaccine spectrum, that's neither here nor there. But at the time, it seemed like it was super, super urgent. Like every day really, really mattered. And so it turns out that to do a successful vaccine trial, what you really need to know is where are the people going to be getting sick the fastest, right? Like if you wanted to do an Ebola vaccine trial, you couldn't do it in Manhattan. Nobody's catching Ebola in Manhattan, right? The way a vaccine trial works is you split people into a placebo group and to a test group. And then you put them in an area where they're likely to be exposed, and you hope to measure the difference between the people who got the vaccine and the people who didn't get the vaccine. And as soon as that gets to a certain size, then you can say, aha, my vaccine works, and you can pass your trial and start administering and distributing the vaccine. So our plan was figure out where, because it takes time to recruit people in trials, figure out where the virus was going to be hot in the US 6 weeks from now, and then tell Moderna and Johnson & Johnson and all the others that are producing the vaccine where to go and recruit people. Turns out that's really important. We did the math. We think we actually shaved about 6 to 8 weeks off the Moderna vaccine trial, which is the one that most people ended up taking, right? The 2 shots. And that was wild. That was a really crazy project, mainly because we could have done so much better if it hadn't been for the tooling problem. Like the tools that are out there for building and deploying these types of machine learning type solutions in a really real way suck. They're the worst. And I'm preaching to the choir, I hope. There are really kind of 2 categories of tools when it comes to, well, 3 categories really. Low code, no code, which we dismiss out of hand because it generally doesn't work. And then you have like notebook environments like Jupyter, say, and like a VS Code type environment like PyCharm or Spider or whatever it might be. Notebooks are great for like prototyping, visualizing data, instant feedback, you know, but at the end of the day, they were built by academics to be used as classroom scratch pads, right? So if you've ever used a Jupyter notebook, how many have used the notebook? Yeah, okay, awesome. You guys are my people. This totally works.
Don't identify students.
So yeah, if you've ever used the notebook, you know that you end up with a bunch of tabs open, and if your computer crashes, you have to open it up and rerun everything because it's in memory. And almost every Jupyter notebook runs locally, so you've got to download the data and figure everything out. And then if you want to send the notebook file to somebody else, well, then they've got to worry about like dependencies and do I have the same version of NumPy and like all these kind of those kinds of issues that go on. And they're, you know, they're great tools for what they are, but at the end of the day, they're scratch pads. So that's one hand. Great for data analysis, horrible for production. And then on the other side, you've got like your PyCharms and your VS Code and so on, which are great for like writing stable code and for deploying and production and stuff like that. But they suck for data analysis because they weren't made for that. They were made for like software engineers writing apps and things like that. So the weird thing about AI is the fact that it's so popular and so like in demand. Nobody's ever really built a development environment for actually doing it with code. Not since SAS really, and they stopped innovating in like 1985. So how many SAS users? My brother. So anyway, so that was the problem. The main problem we had with that project, wow, that's small, is just trying to figure it out so that we could work effectively in a way that was as fast as possible. Because there really was a feeling that if we didn't get it done today, 1,000 more people would die. You know, and that was legit. So I had a guy in, where did Jonah live? Was he in Austria?
He was in Austria.
Yeah, so we had a guy in Austria. We had a guy in Singapore. We had some guys in India. And we were working in Jupyter Notebooks, trying to build this simulation that would tell us which were the right counties to go and recruit in so that they could find the right people for the right trials to make them go faster. And we were doing crazy things. Like we were emailing Jupyter Notebook files because you can't really manage a notebook in GitHub. Like, you know, that's a nightmare because every time you open it, you created merge conflicts, right? So it's like, so that's a nightmare. And then, you know, so anyway, you know all the problems. But things like your technology stack. So once we had the code written the way we wanted it, once we had the simulation going and we wanted to rerun it on a regular basis, trying to set up like a continuous deployment kind of thing where we could update the code and rerun everything and have it all the tests run and stuff like that. That's a pain in the ass. And most data scientists don't know how to do that stuff. Or well, at least, I mean, you have to be an ML engineer before you sort of get to that level. And so we had like engineers on the team where we go, okay, we wrote this code and we want it to run all the time. but we are data scientists, right? We're hacks at Python, or at least I am. I'm a horrible coder. And I can, like hack my way through building a model or writing a simulation or something like that. But when it comes to like converting that into production code, suddenly you have this bottleneck where you need DevOps support to spin up some kind of a Kubernetes cluster to host your model in some EC2 whatever, and you don't even have permissions to do that in the first place, even if you knew how. So that was a big problem. And then we had a lot of trouble with the being able to sort of like collaborate across teams. So as we're passing stuff from one person to the next person, it's all local. And so, yeah, if you've ever worked in a notebook, then you know after you've had it open for a while, every variable that you've ever created is in memory, even if you delete that line of code. And so it happens to me all the time. You're running stuff, everything's working just great, and then you restart your computer and nothing runs. Why? Because memory got cleared when you restarted the computer. And so now you have to go, all right, I had a variable and now it doesn't exist. And I don't know why my code won't run. That kind of stuff was a big pain, especially when you're passing that file back and forth between people to follow the sun so that you can keep working because 1,000 people are dying every day. And, that kind of thing is going on. We had our people working with us as well. And then we had SQL guys too, because we built our own data warehouse for this thing. Because every different state was reporting their data in a different way. And so we built this whole data warehouse to kind of capture all of the daily reported deaths and new cases and stuff like that. So we had a bunch of different people writing in a bunch of different languages. We had folks in notebooks and folks in coding in like a PyCharm or a VS Code. And so everybody's in sort of a different environment doing their own thing. And so you can imagine, all right, how am I going to keep track of whose code is where? And if I want it all to sort of work together, then I'm going like cross environment to make stuff actually go. So anyway, can y'all relate to some of this stuff that I'm talking about here? Like trying to work with a team with diverse talents to get stuff built and actually deployed and running on a regular basis. This is pain, right? Let's have some participation. What's resonating here? Have you guys somebody volunteer an experience, something similar that you've worked on with your team? Yeah, don't be shy. Go.
I mean, this is a problem we run into all the time. The data scientists will be like, we've got this amazing project we've built. And they send it to me and it's like a 10,000 line script. I have to like convert it into like software engineering mode of like everything's like abstracted and decoupled into separate files and it can run in production. And I'm like, my head hurts and I have to ask him questions all the time. It's hard.
Yeah, we have that problem. So you'd have a data scientist train a model and then an engineer that's supposed to take that model. They don't know anything about modeling or anything like that. And so they're trying to take this thing that's written in, some crazy math, whatever, and turn it into something that's actually workable and stable in production. And sometimes you lose something in translation, right? Like that's a real problem for sure. So I quit DataRobot in 22 October, something like 21 maybe. Anyway, and I just decided to take some time off. I took about a year off, got super bored. And I was on LinkedIn and I got a message from the dude in the middle there. Is that a laser? That dude. His name is Philly, and he's Irish. Zerve is actually based in Ireland. These two guys both live in Ireland. And Philly sends me a message on on LinkedIn. And he says, you're not going to respond to this. And he really reached out to pick a fight. He wasn't trying to sell me anything, but Philly's view, Philly and Jason, the other two founders of Zerve, had been going around talking to data scientists. Philly is a sales guy. He is the ultimate sales bro. And Jason is an engineer. So that's their kind of skill set. So Philly had been going around talking to data scientists for the last year and a half, asking them about their pain points in their job. And he was convinced that the low-code, no-code stuff was bogus, that you can't actually generate real value with low-code, no-code tools, and you have to be an expert to actually do this kind of work. Which, of course, I completely agreed with, because I'd spent the last year bashing my head against the wall trying to make this simulation work so we could save 1,000 people a day, right? And so I did respond to his LinkedIn message, And I kind of advised them for a little bit. And then at the end of the day, they didn't really know what they wanted to build. And so I got on a plane, flew to Ireland. We met up in Dublin, had a few pints of Guinness, and decided, because I knew exactly what we needed to build. And it turned out that we made a good team. So those are the three co-founders of Zerve. And what we decided was that we needed to try and build a development environment that was built for data scientists to actually help them kind of solve these problems in a sensible, reasonable way that wouldn't require them to have some of those same problems, like the collaboration problem and the bottleneck problem with DevOps and the cloud orchestration problem, the multi-language problem, like all those problems. We thought, we know how to solve these. Like we can build something that will actually work to try and solve these problems. So we did that. And we built a prototype of it and went to JupyterCon in Paris and launched it. And at the time, it was very, very beta-y. And we could do a demo, but if you clicked anywhere in the wrong place, it would crash. So like it was, I say demo, it was more of like a guided clicking situation. But people seem to really enjoy it. We thought that we'd get booed off stage because at the end of the day, back then our messaging was notebooks suck, and we were at JupyterCon, which I thought was hilarious. But we got some good feedback, and spent probably the next 9 months, kind of refining what we built, building it into actual real software. And then in January of last year, we launched it for realsies, like general release. And we've kind of been cooking since then. So I thought I would take the rest of my time to kind of just show you what we built. Love to get some feedback. If you see stuff that you like, you can get a free account. I'm not selling anything today, but I would love some feedback on what we're building and some thoughts on what's going on there. So any questions before we kind of dive in? We're a quiet bunch.
Sometimes.
What's that?
Sometimes we are.
Sometimes, okay. All right.
Said anything controversial?
I haven't said anything controversial.
No.
Okay. All right. This is what I made for my daughter for Christmas this year. Here's Zerve. My daughter loves to cross stitch. You guys know what cross stitch is?
Yeah.
Anybody not know what cross stitch is? It's like you take thread and you sew X's onto a fabric grid, and the X's make a picture, basically. It's like a needle pointy kind of thing. Something your grandma would do, maybe. But my daughter loves it. She loves cross stitch. And so for her birthday this year, she turned, how old is she? 18. I wrote some code to take an image and convert it into a custom cross stitch map. Right? So it's fairly straightforward, right? Because an image is basically pixels. And so if one pixel corresponds to one X on the cross stitch, then you just have to reduce the resolution of the image down to the right size, and then map each color to an individual thread color, which was probably the hardest part, is trying to figure that out. And then you just have to dump that out and make a little map where you say, okay, all the X's in this grid, that's green, and all the Y's are, blue, and so on. Right? So that's what this project is. And so it turns out that the main company that does this is called DMC. So you can go on their website, and they actually map their own colors to RGB values, and that works pretty well. So that's this guy. So in Zerve, each little node in the grid, the code runs from left to right, and so each block, the connections between the blocks represent the passage of data. So like, for example, let's say that you were training a random forest and you build that model, and let's say you build it in a Jupyter notebook, say, and you want to deploy it. What are the steps? What do we do first? I've trained it. I've got my training data. I've tuned it. I've done my cross-validation.
Too dark, sorry.
I don't mind it.
I know.
Okay. So I've done all my cross-validation. I'm happy with the model, and I want to deploy it so that somebody can hit it with, say, like an API and get a prediction back. I want to send it data, and I want to bounce back.
Throw it to our colleague. Email him the notebook.
You're the ML ops guy. What do you do? What are the steps? I send you my notebook. You open it up.
I don't think I could contribute the whole thing, but one key part is if the random forest is trained on a certain format of data vectors, you need to make sure that the live data matches that exact same format, or else it's not gonna run right.
Yeah, that's super thorny, right? Because a lot of times the data that was used to build the training data set came from somewhere else. And so you got to make sure you don't have like target leakage that's gonna feed in. So you got to make sure that the API, however you build your API, fast API or whatever, that the structure of your input vector matches the structure of the training data, right? You got to serialize that model somehow, right? Like in the Jupyter notebook, I can run it and train it, but it's in memory. And so I need to write it into a file and put it somewhere so that I can actually deploy it on some server somewhere. And I got to make sure that I probably have to Dockerize it because of dependencies and stuff. Like I want to make sure we're using the right versions of the right packages and libraries and stuff. And I probably need some server spun up somewhere that can handle the requests and things like that. Like there's a lot of steps involved in actually deploying that thing. And that's because almost every tool that you work with today is in memory, right? So whatever you train, it's going to be in memory, and you need a DevOps engineer to kind of help you take that model and put it somewhere so that it can actually field requests, right? So that was kind of the first thing that we focused on, is that you don't really want your storage and your compute to be happening simultaneously. So we split them up, right? So when each block runs, so when I go into this block here, say, what I can see on the left side is all the stuff that it's inheriting from upstream. So this DMC colors thing, this is that the JSON that shows me the RGB for each color thread. And then here's my code. So I'm taking this as input, and then the code executes, and here's all my output over here. Right, so yeah, it's kind of cool that one thing you can do in this kind of layout is you can look at your data frame before you run your code and your data frame after you run your code, and you can compare, right, and see what your code actually did. So there's some cool debugging, because in Jupyter, every other cell is print df. You know what I mean? So being able to preview your data is super useful. But what's actually happening under the hood here, when I click run on this block, what's happening is that it's spinning up serverless compute. So in this case, this block is using Lambdas, AWS Lambdas. You guys familiar with Lambdas? Yeah. So it's spinning up compute specifically for this task. It executes the code, and then at the end of that execution, it takes everything in memory and it serializes it and it caches it and it stores it on disk. So that every artifact of your analysis is stored and serialized automatically at every step along the way. So it makes kind of keeping track of what's happening with your data and where your models are and all that stuff really, really straightforward. So if I train that random forest, then somewhere over here in my output variables, there's going to be a random forest that is serialized and out there ready to be touched, ready to be accessed by whatever, externally from maybe something in Airflow or some whatever. Maybe I can make an API and reference it directly from inside Zerve. There's lots of things that I could conceivably do with that. And so that's the first thing that that was the big breakthrough for us, because we actually sat down with an engineer, this guy Mike, who's also Irish, and we were explaining to him how a notebook works, how no matter where you were in the notebook, you could execute a cell and it would change the entire global variable space everywhere. You know what I mean? And we're explaining this to him, and he says, "No, you guys have misunderstood. It can't possibly work that way." We're like, "No, really, we know that's how it works." And he goes, "No, I don't believe it." So we pulled it out and we showed it to him, and he was like, "Hey, that's how that does. That's crazy." And so we were like, "All right, what we need is something." And that's the reason that notebooks are inherently unstable, right? Because if you run the wrong cell in the wrong order, or if you run one cell multiple times, you can get really wildly inconsistent results. So there's no guarantee. And that's why if you open a notebook, a lot of times you'll have instructions on how to run it. It'll be like run cells 1, 2, 3. Don't run cell 4. Run 5 twice, and then come back and then run 4. Like you'll see that kind of stuff in comments inside of Jupyter Notebooks when you're dealing with the data scientists with my level of coding capability. Down here. But that's the problem with notebooks, is that they're inherently unstable. And so when you do it this way, every block starts with the state that's fed into it. So in this case, this block right here is getting objects, data, from each of these 3 previous blocks. And so the way I've structured it here is that these are all the functions that I'm using in this process. So this is a function to crop and resize an image. And then here's some constant values. These are like user inputs that I wanted to use. And so these are all feeding into this block. No matter how many times I run this block, it's always starting at the same place with the same values. And so sort of by architecture, it's guaranteed to be stable. No matter how I run it or who runs it or how many people run it, I'm always guaranteed to get exactly the same output every time. So suddenly I have like a stable environment for actually doing my development that gives me real-time output. And so this is the image. Maybe I shouldn't show that. This is the image that she wanted, my daughter wanted. This is me in a tiny little sombrero. And so she's actually working on that cross stitch right now. So anyway, maybe not the best image, but it is what it is. And so you can see what's going on here is that as the code runs from left to right, each block is passing its data forward. And so if we jump to a different example, this one's a little less whimsical. This is a credit default data set. Has anybody heard of Lending Club? I don't know if they're still in business anymore, but it used to be that it was like they are
Actually, one of their.
Yeah, I was gonna say, I think
Oh,
they
look
have
at
an
it.
office here, yeah.
used to be, and you may not be able to anymore, but used to be you could download all their data and build your own credit default. And the idea was that I could go in and I could invest money and like loan it to people, either like partially or fund an entire loan as a way to like invest, right? So it's like Uber for loans, basically. And so you could download the data and build like a credit scoring model if you wanted to, and try to pick the right loans. And the idea is find the safest loans and with the highest interest rates or whatever, and make that kind of work. So you can download their data, and that's what I did. This is lending CSV right here. And so that data set right here is being read in. And you can see here it is. It's being read in to as data frame. And one thing you'll notice is that the interest rate variable here, anybody notice anything unusual about this variable? It's a string. Yeah, data scientists, plenty of people. Yeah, it's a string. There's a % sign in the raw data, so it reads it as a string. And so this line of code just takes that string and turns it into a float. So that's super convenient, right? I can compare before and after, see that my code actually did what it says it did, and that's pretty awesome. But these are all persisted, right? So here we're doing like a really simple data pre-processing pipeline, like standardization and missing imputation and stuff like that to just prepare the data. Then I'm training 3 models. So here's that random forest, logistic regression. Here's a support vector machine. And then I'm looking at some ROC curves and then just some basic model comparison. Oh, and then we've done some LLM integrations. And so here I'm asking Claude 3 to explain what the code is doing. And we'll look more at the LLM stuff later. But what you can do here, Zerve is built in layers. And so if I click add layer here, I can add an API layer. And this is from an old demo, so I'll just delete these. In fact, I'll just delete this whole layer. I'll add a new one. And so I can go in here and I can say, okay, we'll call this SLC, great demo, whatever. And so that's creating an API endpoint. And I can specify security and all that stuff. If I want to add files, I can do all that. And then it gives me the capability of creating a bunch of routes. So maybe I want 2 routes. Maybe I want a get route and a post route, say. So I'll go in here and maybe we'll call this predict. and we'll make it a post route. I can tell it things like what kind of payload are you going to expect? So if I want to say, okay, you're going to get a dictionary and these are the elements of the dictionary and these are the data types that you should expect, it'll do like data validation for me and say, okay, this is bad data. So you can return, like some error if it gets bad data. Then I can set up a test. So if I want to, give it some sample data to start with, see how the API works. And then it's as easy as just adding in a Python block to say, what do I do with the payload and what do I return? And so it's super straightforward. If I want to, I can go in, I can find that random forest where I built that random forest model, and I can attach it to the API so I can reference it directly. So I don't have to worry about serializing anything. I don't have to worry about like, where am I going to store this thing? It's already out there. And so I just have to say, okay, do this with the payload. So I might do like a rf.predict kind of thing, and then a return a response. And once I write that code, I can click deploy. And then what that does is it spins up all the API stuff so that it just handles it with lambdas. So that when I get requests, it just scales to handle however many requests I get. But of course, you may not want to deploy it in Zerve. You might have another system. So you can actually go down here once you've deployed it, click download source. And that'll give you the source code and the Docker container and the Kubernetes setup files and all the API docs and all that kind of stuff so that you can actually take it and deploy it wherever. Go ahead and deploy it. So there's that API stuff too. And all that is possible because of the way we kind of handle the data when we actually do the calculations. Okay. Let me show you a few other things. How long do I have, by the way?
As long as you want.
As long as I want?
Usually we go about 45 minutes, so it's like 10 minutes more.
10 minutes. Okay. This is a really cool thing that I did the other day. I wanted to see if the different LLMs were biased. So, and of course they are, but in what way they were biased. So I started out by saying, all right, give me a list of 100 questions that you might see in the essay section of the SAT. So I want 100 questions, and it comes back with it. So this is we call this a Gen AI block. And so you can go and, in this case, I'm asking ChatGPT 4.0, but this is integrated with Bedrock too. So I can ask Claude, I could do like Anthropic models, I can do Titan, whatever. There's a whole bunch of them that you can query. You just have to pick your model. And so this gets returned. Here are the questions. Is it more important to be liked or respected? So that's the first thing. And then we have this thing that we call the fleet, which we've actually patented. It's pretty cool. Because the way we do the calculations is serverless, turns out it's really easy to spin up a lot of them all at once. And so in this case, I've got 100 questions. So I could send each of those questions to an LLM and say, answer all 100 of these questions in like a loop. But it turns out that it costs about exactly the same amount of money to send 100 lambdas simultaneously to these LLMs. And so that's what I did. We use what we call the spread function. And so we take that list of questions and we launch a fleet job. And so here I just have like a dynamic prompt. So answer is if you are a high school senior, and then I pass it the particular question. And your answer should be no more than 50 words. And so this launches 97 concurrent runs, because it turns out that even though I asked for 100, ChatGPT only gave me 97 in this case. But this launched 97 concurrent runs. So each run here corresponds to a different question, and they happen simultaneously. So this block ran in 17 seconds. Whereas if you'd actually done it in series, well, you know how ChatGPT returns info, right? It's slow. It would have taken 10, 15, 20 minutes to get all those answers back. But here we go. So we got all these answers. And so this is Amazon Titan. That's Amazon's large language model. This is Claude 3 Haiku. This one is Mistral. And then ChatGPT 4.0. But I asked them all exactly the same question. Go ahead and answer these 100 questions. So that's 400 runs. And also in Zerve, I can run as many blocks simultaneously as I want. So I launched all 4 of those. They all ran simultaneously, all in under 20 seconds. So that's 400 LLM requests that happen like in less than 20 seconds. It's fantastic. So I get all these answers back. And then I asked it to evaluate the preceding all four models and pick which one it liked the best. Because I thought, okay, does Titan favor Titan answers? Or does Titan favor ChatGPT? Or does Mistral like Claude? Like, would they be biased to prefer their own answers when you ask them a question? It's funny, right? It's interesting. So that was the next question. I named the students, so Titan, Claude, Mistral, and GPT. I said, okay, evaluate which one did the best. Okay. Here's the results. So here is what ChatGPT said. ChatGPT has some, it doesn't like itself. It has a little self-loathing going on. It really likes Titan, not so much Claude and Mistral. Okay, so this is a count of who won for each of the 97 questions. So ChatGPT does not like itself. Mistral loves ChatGPT. All the other three, ChatGPT won. But if you notice, the second choice is always themselves. Mistral came in second, always. And then Claude, switched on this one. So Claude has some self-loathing as well. GPT is clearly better. And it's only 4.0. I didn't even use 0.1, which is clearly better. And then Titan really is in love with Claude. So anyway, it's kind of interesting. But we're integrating with all these LLMs because it turns out that the whole Gen AI code assist thing is like, it's the way people code now. Like you don't start with a blank screen anymore. At least I don't, because I'm a shit coder. I just go to ChatGPT and say, hey, I need to do this. Write me some code. And then maybe I have to tweak it a little bit. More likely I have to revise the prompt to say, could you change this for me? Because I have lost all capability as a coder. But anyway, so that's pretty fun in terms of like an integration with Gen AI. There's a whole bunch of other stuff here that we haven't had a chance to talk through. Things like an integration with SageMaker, scheduled jobs. So if you need something to run on a regular basis, that exists. We've got an integration with Snowflake, so you can run using Snowpark as compute, that kind of thing. And then I didn't talk about language interoperability. So it turns out that because of the way we serialize the data, you can have Python, R, and SQL all in the same project, right? So remember I said each block serializes every artifact. So if we serialize a data frame, like for example, as a Parquet file, well, R knows how to interact with Parquet. And so you can connect an R block to a Python block and all your basic data types transfer automatically. So I don't have to convert code. There's no translation happening. But I can connect and use like a pandas data frame. I can write R code to visualize it using, whatever I might want to use, which is great if you have a multi-team kind of thing going on. And then the last thing I'll say, if you have multiple people in this document, it's a Google Doc-like experience. You can see their cursors. We can all interact at the same time. You can write comments. You can see the code that they're running. Has anybody tried to use Colab, Google Colab?
It works horrible with real-time
Oh,
cloud.
it sucks. Yeah, trying to get more than one person in the app, right? Your experience, yeah. We've solved that problem. So this is a very Google Doc-like experience so that if you've got multiple people in there, you can have a team actually coding simultaneously in different parts of the project, all running code simultaneously. And because of the way the architecture works, it doesn't break. Delays, you don't have to lock cells. Like if you've ever tried, any of the notebooks out there that allow that kind of thing, they all have a very questionable experience when it comes to that. So the whole collaboration thing is pretty cool too. Okay. You can manage custom requirements really easily. So no more dependency problems. It's easy to add packages. And then you've also got like an integration with GitHub. If you want to source control, that kind of thing. So like here's for this guy, I've made a few pushes to a commit to a branch for this cross stitch maker. Oh, and I've also got an R Shiny app, so you can host apps within the application as well. So lots of stuff. Anyway, let me pause here because I'm pretty excited about it. I think it's a really awesome setup, and so I'd love to field questions and then stop talking. What do you guys think?
I was just curious, does it just track dependencies with variables? So like if you make a change in an earlier cell, it'll track previous changes, then it'll push everything downstream.
So we made some choices there. So if I change an upstream cell, the network is aware that something has changed, and so the color of the blocks will change. So green here means that the block has run successfully. But if I change something, it turns purple. And it also turns all the blocks past it purple to say, okay, you don't have the latest code, but it won't break them. So like if you have two people working on either ends of the graph and the guy or gal upstream changes something, this guy can keep working. But the block will be purple so that he knows, okay, something happened up here that you need to refresh. And so you have to manually update the actual values of the variables. It doesn't flow through automatically. But the graph is aware that you don't have the latest data. So we didn't want to disrupt. We wanted the collaboration thing to keep going. So that's the choice we made.
How does version control work with dependencies and like merge conflicts with your integration with GitHub?
Yeah. We have a dialogue for handling merge conflicts and stuff like that. So same way it would work in like just GitHub. So you just manage the conflicts like you would.
This seems like a very involved app. I'm just curious how many developers you have working on this project and how long you've been working on this project.
We started probably a year and a half ago, and we've got 25 people or so working on it. We've raised about $12 million. So yeah.
What does deploying this look like? Does it just go to step functions in AWS or what happens?
And we're in the AWS marketplace. So it's like a 6-minute install. It's designed from the get-go to be self-hosted. So at the end of the day, nobody wants to send their data out to a third party to do analysis. So it runs just like Databricks. So Databricks runs a control plane that has certain permissions to be able to spin up compute, but all the compute and storage happens in the user's VPC. We do have a SaaS environment that if you guys wanted accounts, you get a free account in. That runs on our AWS setup. But yeah, all of our customers are self-hosted at this point. We can support other clouds. Right now that's via like a Kubernetes type setup. It's not using like native tools like we do in ABA. We were born on AWS because they give you the most free credits. So.
So I can see how this, like, if you're going from notebook development, this would be a big step up. How does it work if I have like massive functions in one spot? I want to use those in 5 spots. I need to import it, multiple little windows.
So we have what we call the asset library. So if I go, I don't have many assets on this particular account. But like, for example, you can set up functions and classes. If you have some reusable code, maybe a custom class. In this case, I like to put all of my AWS keys in there. And so we've got like secret manager built in and stuff like that. And then when I go into my actual project, I can go into that asset library and I can add all of that stuff. So in this case, I've already added a few. I've got a Snowflake connection. I've got a connection to Weaviate because there's a vector database in this particular project, some API keys, stuff like that. So if you do have an API or if you do have reusable code, you can put it in your asset library and share it just like you would a Google Doc or something like that. Or you can import stuff directly from like GitHub. So if you have like a custom something or other set up on GitHub, you can import it directly from there as well. You don't have to use our asset manager if you don't want to. Does that answer your question? Yes.
Cool. Any more questions? Let's Greg, right up close.